Hi guys, this is James Boyce here for RL Tuition. Today we're going to be looking at solving physics problems related to connected bodies and their motion. We're going to be using simultaneous equations. Simultaneous equations isn't the simplest method to be able to solve these kind of questions for. However, it is the most reliable and the most easily applied to all kinds of different situations, no matter how complicated they get. And for that reason, we're going to be looking at it today. So this problem here, very basic one, just to kind of see how it works. We're looking at a 10 kilogram block connected to a 30 kilogram block around this pulley here. Both of them are being pulled down with gravity and being pulled by each other. What we want to find is the acceleration of this 30 kilogram block, which will also be the acceleration of the overall system as they're connected together. We're just taking gravity to be 10 meters per second squared, and we'll get going. So the first thing you're going to want to do is draw a force body diagram for each individual weight, okay? And so we'll start with the 30 kilogram one here. We've definitely got gravity acting on it, and I'm going to draw the forces not coming from the center just for space reasons, but you should probably draw them from the center of your block. So here, gravity, 30 kilograms times the 10 meters per second squared. That's going to be 300 newtons acting down. And we're also going to have the tension force from this string here pulling the block back up. Similarly, on the 10 kilogram block, we're going to have the exact same force. We're going to have gravity pulling it down. That one's going to be for 100 newtons, at this time 10 times 10. And we're going to have, again, this part of the string here pulling it up. And that tension force here is going to be exactly the same as the tension force over here. So it's also going to be T1. This is the first very important rule to remember that applies to all connected bodies. Whatever the force is on one end of the rope will be the same force on the other end, and they'll both be pointing towards the middle of the rope. In this case, because it's in 3D and the rope's curved around this circle here, it's a bit confusing, but essentially they're both coming towards the center of that rope there, which in this case is up for both of them. Now that we've done that, we can write force body equation for each one. We know that F equals ma. That's our most fundamental rule when solving all kinds of motion questions. We'll take the 30 kilogram block first. 30 kg. The net force on this is 300 minus tension 1, because tension 1 is acting in the opposite direction to 300 newtons. We need to make sure that whatever direction we pick to be positive, we keep it consistent throughout the entire question. So in this case, I've chosen down to be positive when I picked 300, and therefore anything moving up needs to be negative, in this case T1. And that's going to equal mass times acceleration. Mass is 30. 30. Acceleration is unknown. We'll just call it A for now. Now the 10 kilogram block. This one, we've got 100 newtons going down. Tension is going up, so that's going to be negative again, and it's the same as the first tension. And this is going to equal, again, mass times acceleration, and it's going to be 10 times A. However, if we think about what's actually happening in this problem, the 30 kilogram block is heavier than the 10 kilogram block. So the force on this side is going to be larger, which means this here is going to end up being pulled down. That means that this 10 kilogram block is going to be being pulled up. So as they're connected, the accelerations will be the same. So these two numbers here are the same. However, the directions will be opposite. That's why I left this little space here, because in fact this should not be 10A, but negative 10A. So we do that. And now from here, we're just going to proceed like a completely standard simultaneous equation that you've done in maths. We've done all the physics at this point. We just need to solve these two now. So what I'm going to do is go 1 minus 2. And that's going to give me 300 minus 100 is 200. negative T1 minus negative T1 will cancel, because that's going to be minus T1 plus T1, 0. I'll just write that in here, plus 0 T1 equals 30A minus 10A, so plus 10A, 30A plus 10A, 40A. Divide both sides by 40, we're going to get A equals 200 over 40 equals 5, and the units for acceleration will be meters per second squared. And that's all you have to do to solve this kind of connected body question using simultaneous equations. You might also be asked to find the tension, and that can be solved the exact same way, solving for tension first, or after you get A, which we've already done, take this, sub it back into either one of these equations, and then find T1. Hopefully you found this video helpful. If you still have any questions, make sure to leave them down in the comment section. In addition, we've got a problem here for you to do before your first class at RL. What we've got here is a 5 kilogram block hanging off the edge of a table connected to a 20 kilogram block which is on the table. So the gravity is only pulling the 5 kilogram block down, but they're connected. So try and apply the same principles we just showed you here to find the acceleration of the whole system in this case. And additionally, if you want, try and find the tension in the actual rope.